As I was saying, today's class, the slides are over here. We're going to learn about testing in Node.js plus Express. There are popular libraries that let you do testing in a MERN stack project, be it a Node.js backend having Express in it, be it a React frontend, or be it Next.js. Support for Next.js testing is a little weird at the moment, but React frontends you can test fairly well. MERN stack Node.js backends you can test very well. We'll be focusing on Node plus Express today. We should cover Next.js as well because all of our projects that exist on GitHub are all Next.js, which means everything we're learning, even though it works out of the box on an Express code base, it will not work on a Next.js code base. So since we have to anyways add tests to all of our repositories, there'll probably be a follow-up video or the live next week. We'll be on adding testing to a Next.js application. Today it's going to be Node.js plus Express specifically. We will learn about how to test an Express backend. We will learn about this thing called mocking. If you've done tests, you know. If you have not done tests, then you probably don't know. But fairly common term, not just in a Node.js test, even in Java, mocking and spying are, popular things that you do / jargon that you need to know. Jest and vtest are the frameworks that we are using. There are many frameworks in JavaScript that let you do testing. Vtest is probably going to become the popular one eventually. Jest is the oldest one, or maybe not technically the oldest one, but the most used one. But it was built for JavaScript initially. Slowly there have been efforts that people have made to make it compatible with TypeScript, but can lead to a lot of errors. Vtest is written by the people who have written Vite, which we've used for React from time to time. I'm assuming that means Vercel owns it transitively because I think Vercel owns Vite. I could be wrong, but high level this might be the eventual library. It's highly compatible with Jest, which means if you have a Jest code base, it's very easy to move it to vtest. We'll do both of them. We'll understand how to write tests in Jest and vtest. We'll understand the difference between unit tests, integration tests, and end-to-end tests. Even though we're just writing unit tests today, this is something we should do. This is something I've seen done in very few places, and it's not really needed. It leads to a lot of overhead for developers because developers have to start the database locally for tests to run. But it's a good thing to have, especially if you want to have a very strict code base. So we might do this at some point, but not today. Today we'll only be doing unit tests. We will understand the difference between all three of these though. And what libraries should you use for integration tests? How can you do integration tests? And same for end-to-end tests. And lastly, how to integrate testing and coverage in CI/CD. After you have written your tests, how can you, if for example, this is the repository for today. If you go to the pull request section here, I've created two pull requests. One has a tick and one has a cross. How can you, after you've written tests, add a CI/CD pipeline? So if developers come and make a wrong change, for example, this developer made a wrong change. He flipped some things in the code base that would break the final code. How can you catch them right at the pull request? How can you make a pull request workflow fail if the tests fail? And you don't have to actually clone the person's code and actually run it locally. These are the 4 things we will learn. All the code is here. Feel free to look directly at the code. And if you feel it's straightforward, feel free to skip. This one is the sort of biggest one / the most difficult one, although we'll slowly try to build up to it as you go through all 5 of these assignments. That's a brief introduction. Let's get right into it. Let's kick things off. But maybe before that, do we know what testing is? Have we done testing before? Let me just do a poll to understand. Do I need to explain what testing even means or what automated tests are? Do we know what testing is? Little bit high level. Can we directly dive into the code, or we don't know what testing is? Alrighty. All good. So let's just do a little bit of an overview. Until now, we've written some Node.js code. Usually the Node.js code has looked like this. Okay, import express from express, and then a bunch of other code. App.get, res.json, something like this. This has been our Node.js code we've written until now. How have we tested the code until now? Harkirat, I would start the process by running node index.dist / index.js. And then I would go to Postman and try to hit the endpoint. This is the endpoint that I just created. Let me hit the / endpoint and see, am I getting back the right response or not? That is how we have done testing. If we have a full stack application, we would start the backend, start the front end, and test it out locally. this is a decent way to do testing. This is a decent way to know. How would you know if your code change has worked? If I say, yaar, change this function a bit, you will add some logic, const a equal to 1, whatever, and then return a, let's say. Whatever change you made, you can logically think, this code change probably does what it's supposed to do. But how do you test it right now? Right now, you run the Express server by literally doing node dist/index.js, and then you go to Postman and actually hit it. There is no automated way for you to test it. What if you could write a separate file called index.test.ts, let's say, where you write the code, I want to send a request to the /endpoint. And I want to make sure the response that I get, the a value there should be 1. I need to somehow assert that the response that this guy returned, as you can see, this returns, defines a variable and returns this variable to whoever is calling it. Rather than testing this in Postman and you're clicking on send and checking, I got back a equal to 1. What if I could write a script of sorts? And in the script, I write all of this code. Const res equal to await request / what is request? You can just think of it as fetch / and then you actually somehow assert or do something like this. If res.data.a is not equal to 1, then throw an error. Test failed. What if you could write code like this? Harkirat, I can just write code like this. You have just written it. You have written tests. Yes. This, for all practical purposes, is a test for this route that we have written. I can just run node dist/index.test.js after I compile this to JavaScript. And if I press enter, this will try to hit the server and automatically figure out, is there anything broken in this code base, rather than you as a developer starting it and going to a GUI and clicking the send button again and again. That is what automated tests are. If you remember, I showed you a pull request. Two people tried to do a pull request. They made some code change. For example, this person made some bad code change. Since I have written some tests somewhere, those tests were able to figure out, the test has failed. Even though I'm expecting a equal to 1, after this user's changes, a becomes 2. Let's say the user made this change. If the user made this change, the test will begin to fail. And I, as the maintainer of the project, now know, the test has failed. I will not merge this because I will ask them, hey, tests are failing. Can you check what's up? Something like that. And then they will eventually fix it. They will re-push to this branch and then eventually this might succeed. If you look at the other pull request, in the other pull request, I have not done anything. If you look at the changes here, I've just removed a line of code or added a line of code, something like that. No code changes made. And hence the tests still work. If you look at this, it says all checks have passed. This is what automated testing is. You wrote a file. Inside the file, you wrote a bunch of test cases. This, of course, doesn't check everything. You cannot write infinite test cases and cover every edge case. But you can try to cover the most common edge cases. For example, if I have a simple Node.js project, let me quickly create one. Or simple JavaScript project, let's say. Simple-test, where I do function sum a comma b, return a plus b. Now this is a function that's written in JavaScript. How will I test it? Harkirat, you can log it. You can write const answer equal to sum of 1, 2, 4 and log the answer, Harkirat. If you log the answer, and as long as it prints 6, it means your code is correct. What was my code? This was the code that I wrote. I wrote a function called sum, which takes 2 arguments and returns the sum of the arguments. I called the function and logged it. This is one way of testing it. Harkirat, why do we have to test it? It's so obvious. It's such a simple function. Yes, but this might become a very complex function. What if I say sum and multiply and something else? You should, even though this is a very simple function and you can tell from your naked eye, this will of course do the right thing. You should still write tests. Now this is one way of writing a test. You simply do this. Log it and see how it looks like. Or you can get a little more complex. What you can do is you can create a sister file right next to it. You can say I will create a new file called index.test.js, inside which I will import this function const sum equal to require dot slash index, and then write some code. Okay, if sum of 2, 3 is not equal to 5, then throw an error. Function failed or test failed. Before I run this code, I need to make sure this guy is exporting the sum function as well. So I need to change the index.js function to do something like this. Module.export equal to sum. I think this will work. So this is the code that the developers have written. Until now, you and I have only written this code. We have never written tests. But today, we're trying to write some tests. Let me actually do this. Module.exports equal to an object that has sum. And then let's import sum over here. This is my test. This is my original code. The code writes a function called sum and exports it. The test requires that code or requires the function and checks. Now it should ideally check a few things. This is a simple test, but I can write multiple test cases. If sum of 3, 5 is not equal to 8, then also you can throw a new error that says test failed. Something like this. And then lastly, if nothing failed, then you can log success. So this is one way to write tests. This is a slightly ugly way, but it works. You can say you've written tests for your Node.js code. There are libraries that let you write this in a more fancy fashion, but for all practical purposes, you have written some Node.js code. You have written a test for your Node.js code. Let me try to save this and then run this code. If I go to, what was it called? Totally forgot. Simple test. If I run node index.test.js, it says sum is not a function. I'm mostly not exporting this the right way. Module.export equal to sum is not a function. Let's try this one more time. Else I'll move to VS Code and figure out what's actually up, or someone will tell me in comments. Let's try that. There you go. It says success. But if I change the implementation of the function, if I say sorry, it returns A. If a developer comes and makes this change by mistake, then my tests can automatically check. An error was thrown. Hence, having tests are super useful when you have bunch of developers. In fact, personally, I have felt this pain as too many PRs come. I have to merge that PR and then test it manually myself to make sure everything is up. If we had good tests, then those tests would automatically fail if there was a bug in the code. That is why you need tests. That is why you write tests. Most good code bases have tests, even though they are ignored for a really long time because developers just want to move fast and write code. No one wants to write tests. Are we good to go? All right. We understand what are tests. We can write them in this ugly way, but there are very nice frameworks that give you some constructs that you can use and you should use. Harkirat, why do I need those constructs? Because your full stack application a lot of time connects to a database, connects to Kafka, connects to Redis. And when you're running these tests, a lot of times you don't want all these services to start. You just want to test the core logic of your application, which is why things like mocking, things like spying are something these libraries provide you, which is why you use these libraries. They give you very nice output. This thing failed, this thing succeeded, which is why most of the times, not most of the times, always you will use a library like Jest or VTest. You will not write all of this code naked like we just did. Cool. That is a brief introduction. Now let's write some tests the right way. We've written them the wrong way. But now let's try to use one of these libraries, specifically the Jest library, and try to code this ourselves. All of this code is in this one simple test folder. So if you want, you can look at it here, clone the repository and try it if you don't want to code it. If you want to code it, you can code along as well. Let me reshare the screen for the people who have just joined. Alrighty. Okay, for people who are asking for the track, here is a link to it. Let's follow all the steps here and create an empty TypeScript project and open it in Visual Studio Code. mkdir simple dash, let me actually create a big root folder, week 24 to week 24 to, and then here let's create the very first folder called simple dash app dash 1. We have a bunch of apps to create, so I'm creating the first app, then we'll create the second app, so on and so forth. Let me open this in Visual Studio Code. If you want to try it out, would urge you to do the same, or you can just copy this code over from, as I said, this GitHub repository. Oh, sorry, I should probably post the link to it. It's in the slides. Alrighty, file, open. Cool. Week 24, we have a simple app 1 folder over here. Let me go to that folder. And what is the first thing we do whenever we initialize a Node.js project? We have now done it many times. We do a npm init-y. This initializes a package.json. That's the first step here. What's the second step? npx tsc-init. And this initializes a package tsconfig.json. If you look at it, I have a package.json now and a tsconfig.json. What is the next step that we usually do? We go to tsconfig.json and change the root dir to be ./src, because that's usually where you put all of your source code, and hence src. You should also create a source folder here on the left. And lastly, we change the out dir, if you remember, to dist, so that all the JavaScript that's created from the TypeScript gets stored in the dist folder. That's the first thing that you do. Then you create a source/index.ts file where you will be writing your code. The code we are writing today is the same sum function we just wrote to begin with. So export function sum, it takes 2 arguments, a which is a number, b which is a number, and it returns the sum of a and b. The same function we wrote a while back. But now we won't write a raw test for it like we did. We'll use one of these libraries to actually test the right way and use this framework, understand why it is beneficial, and why most companies use a testing framework than writing everything themselves. After you've written your application logic, I will keep saying application logic again and again because now we have reached tests. Application logic means the real logic that runs in production, that is running on an EC2 machine. Testing logic is the logic that you run from time to time to make sure tests are running, but you don't run it on the EC2 machine. The EC2 machine does not need to even have your tests. So whenever I say application logic, I mean the Express server we might be creating, or this logic that I've written over here. Given this logic, how can I write a test for it? We can either use the native approach that we just used a few minutes ago, or we can use this library called Jest. Let me just show you what Jest is, maybe in Node, but Jest is as the title over here says, Jest is a delightful JavaScript testing framework with a focus on simplicity. It was built for JavaScript. It's not super high TypeScript compatible, somehow has been made that way, but not the best framework to choose if you have TypeScript project. Great framework to choose if you have JavaScript projects. But it works now with everything, including front-end projects if you want. What is the steps to bring Jest into your project? You first have to install these dependencies. This can change. A lot of times you might not use @jest/globals. You might have a different way to import everything that Jest gives you. This is just one of many ways to get it in a TypeScript project. You definitely need TS-Jest, but rather than @jest/globals, you can also do something else. What is that? Don't even worry about. Copy this and bring in the dependencies. What are the dependencies again? ts-jest, which is basically Jest with TypeScript support, and @jest/globals, which we'll be using to import some global things using Jest. These are the 2 dependencies you have to add. If you have a TypeScript project, if you had a JavaScript project, then all you had to do was npm install Jest. But since we have a TypeScript project, we have to do npm install ts-jest. What is dash dash save dash dev over here? It basically means in my package.json, it will appear in dev dependencies and not in dependencies. If I did an npm install express, it usually comes in the dependencies section right here. But since I did a npm install dash dash save dev, this and this, they come in the dev dependency section. What is the difference? The difference is anything, as I said, that doesn't run on your EC2 machine, that you only need during development, is something you should put here just for structure. Other than that, doesn't really matter. If you want, shove it in dependencies. Totally ignore this as well. Now that we have all the jest dependencies, one more thing you have to do is initialize a jest.config.js file. You can create it yourself, or you can run this command npx tsjest config :init, and that would initialize a jest.config.js file. All the configuration that's there by default is good enough. You don't have to make any changes yet. We will eventually be making some changes, but for now, whatever you have in jest.config.json is good enough. Lastly, if you want, you can make your package.json slightly better. Whenever you initialize package.json, you might have seen there is just one script over here called test, and usually just errors out. If I run npm run test, it'll throw an error. It'll say no test specified and exit one, no tests specified. That's just the default thing they put for, this error to pop up on the screen, because there is no tests right now. But now that we have added the tests, or we will be adding the tests, if we had done it the naive way, then the thing to run here would have been node dist/index.test.js. But since we are not doing it the naive way, I don't want this to run when I run npm run test. What does this script section mean? It means whatever I run when I run npm run something, for example, npm run test, this thing actually runs in the terminal. So if I run npm run test, it is the same as running node dist/index.test.js. It throws an error because of course this doesn't exist. And what we really need to put here is jest, J-E-S-T. That's all you have to run to trigger all the tests. Kirat, where are the tests? We will be writing them. But before we write them, this is a cleaner way for you to, now if you run npm run test, then it will start all the tests. There are no tests right now, which is why it says no tests found, exit with code 1. But we'll be writing them very soon. So what have we learned? We have initialized a simple TypeScript project. We changed the root dir and the out dir. We defined a simple index.ts function over here. We exported that function, a simple sum function in index.ts and exported it. We added all the jest dependencies. We initialized a jest.config.js, and we updated the scripts section in package.json to have a test script right there. Lastly, we will be writing the tests. This might feel a little complicated if this is the first time you're writing tests in JavaScript, but you will see the syntax throughout. Open any repository that has tests. This is the syntax that's used specifically. Describe and test is something you'll see very often. Let's copy this over and create a fresh file. There are many conventions to follow. You can create a file directly over here called index.test.ts, or you can create a tests folder inside which you can write a index.test.ts file. Doesn't matter. Jest by default will go through your complete source folder and look for all files that end with .test.ts and try to look for tests there. So doesn't matter where you store it, as long as it ends with .test.ts or .spec.ts, Jest will understand that this is a file for me. I need to run all the tests that exist inside this file. So create index.test.ts, store it wherever you want, and then finally paste the very first test. And let's try to notice how this is different from the ugly test that we just wrote a while back. What did we write? If you remember, see Daisy, we wrote a file. Let me just open that file as well. Simple test. This was our file, right? This is how I wrote tests until now. I wrote this code right here. I required the sum library, and then I wrote all of my test cases one by one. If sum is not equal to this, then throw an error. Sum is not equal to this, throw an error. this is slightly, this works. It's not ugly. It's fine. But what if you could write the code like this? Can you describe? Here I am going to write all of my tests for a sum function, a sum module that I'm trying to test inside this describe block. So 3 things you will have to learn if you want to learn about tests in JavaScript is describe, test, and it. Usually people don't even use test, just describe and it are the 2 things you have to learn about when it comes to writing tests in JavaScript. Whenever you're writing tests, you will be testing a certain functionality together. For example, right now I have only the sum function. But what if I introduce another function called multiply, inside which we multiply the arguments that come in? Now, you would want, this section of my code tests the sum function. This section of my code tests the multiply function. So this top level describe means inside this, however many tests I write would be for the sum function. For example, let's say I write 3 tests. Then I can write them here. And then I can define a separate top level describe for my multiply function. These are the 2 things I have to test. I have to test sum, and these are the 2 test cases for that. And I also have to test multiply, and these are the 2 test cases for that. Kirat, how do you write test cases? What is it? We'll get to. But do we understand describe? Describe says, generally this is practice. You don't have to do this. You can shove all of your test cases in a single describe. But good practice is, you say, I'm going to write all of my sum tests over here and individually write, individually write a bunch of tests that test that specific function. And then, if you have more functionalities to test, you create a separate describe block. What is a describe block? It takes 2 arguments. A human readable thing of what you're testing. In this case, I'm testing the sum function. I can also write testing sum function. That is the first argument it takes. The second argument it takes is a function inside which you describe all of your individual test cases. The very first test case we have written here, and the way to define a test case, just like you wrote describe, you write it, and then you give a description of the test. I'm trying to check, does the sum function work correctly for 1 plus 2? And then inside this, you write your actual test. This is a slightly complicated way to write the test. Let me write it a simpler way. Const sum, or final answer equal to sum of 1, 2, and then expect final answer dot to be 3. Notice I did not have to write this. If final answer is not equal to 3, then throw an error and then catch that error somewhere. No, I can simply use the expect function that this library provides me and say, expect this dot to be 3. As you can see, it's very human readable. Expect is a function. I called that function. Whatever that returned, it has a dot to be key. I called dot to be on it and passed 3. It's like writing a sentence, right? In fact, a lot of times you write this. It should sum 1 and 2 correctly. So it's like completely human readable. It should sum 1 and 2 correctly. And then you do your actual implementation here. You call the function, and then you say expect this to be equal to 3. That is what this line over here will do. If final answer is not equal to 3, just will throw an error. If it is equal to 3, it will not. That is how you write one test case. If you want to write another test case for the same function, you can write it should return the sum of negative numbers correctly. Let's say that's the edge case you're trying to test. And then you can be like const final answer equal to sum of -1 and -2 and expect the final answer to be -3. That is how I've written 2 test cases now. Same you can do for a multiply. Like you can create a similar block to test the multiply function. How do you test it? Since we already in package.json added the test script, if you remember this thing right here, all I have to do is npm run test. and it shows me, hey, this testing sum function is the first describe we're testing. It had two tests, both of them succeeded. If I add another describe here for the multiply function testing multiply functionality, which let's say has just a single test, something like this, describe testing the multiplication functionality, it should multiply 1 and 2 correctly, get the final answer by using the multiply function, which I've imported from index, and then expect final answer to be 2 because 1 into 2 is 2. If I run this test again now, it says first block, these are the two tests that ran, worked correctly. Second block, this is the one test that ran. So that's the benefit of breaking it down into various describes. The final logs that you see are, much better presented versus, everything being you trying to find, where is my test that just passed. Do we understand a simple way to do testing in JavaScript? Let me do a quick poll. And if we do, then we will move on to creating an Express server and testing things over there. %87 is pretty decent. I don't know what the errors might be. Any non-logical way of just trying to answer a few questions. Join late, a few quick recap. Yes, the first argument here, it might have another meaning, but yeah, it's mostly for developers to understand. This is what this specific section is supposed to test. Recap. Let me quickly recap everything. We're learning about testing in JavaScript. Right now, we're on slide number 2, where we're testing a simple Node.js application. The simple Node.js application is this. This is the code that we wrote in source/index.ts. And we're using the Jest library to do the testing. We installed the Jest library and finally wrote tests that look something like this. We imported describe, expect, and not test, but it. We imported these three things from @jest/globals, and we imported our real functions, multiply and sum, from the index.ts file. These are the two functions we're trying to test now. How did we write the tests? We used the constructs that Jest provides us. We said describe. This is what this next code section will test. And then I wrote two test cases here. Test case number 1, here if 1 and 2 are being added, expect the sum to be 3. So that if ever the logic changes, if ever there is a developer who by mistake changes the logic here and says A minus B, then the test begins to fail. If I run npm run test now, you will see it failed. It says 1 failed. So the developer can understand, there is some bug. I made some mistake over here and revert his changes. That is the purpose of using tests. This describe and it syntax is a very common syntax. You can actually nest this much more. For example, you can say testing all the calculator functionality, inside which you can have another describe that says testing just the sum functionality, and have your first two test cases there, and then have another describe for the multiply functionality. So even though you don't do this too often, you can actually nest describes. Okay, inside the first describe, which is saying I will test all the calculator functionality. Inside that, we have the first describe to test the sum function, second describe to test the multiply function. If you did not understand, it's fine. What you learned before is also fine. But if you run this, it will still run the tests, and now you have slightly better structuring. Okay, testing all the calculator functionality will happen here, sum functionality here, and then multiply functionality here. That's the purpose of describe. You can actually keep nesting it as much as possible or as much as you need. But usually you just have one top level describe and a bunch of it statements inside them. That is how you test a simple Node.js app. Let's move to an Express application. Slide number 3 we will now change our application to have Express in it. Now things get a little tricky. Now we don't just have to import a function and call it. We actually have to send an HTTP request. We have to start a server maybe. How do you do that? How can you start an HTTP server? Or if you have Express logic, how can you hit an endpoint, get back the response, and expect on that response that you got? how can you actually send a request, or at least simulate sending a request? And the answer is this library called Supertest. This one right here. This library was written for you to be able to test HTTP servers. Let's see how they do it. First thing you have to do is you can either create a fresh app and start from the top, or we can just use the library that we already have, or the code that we already have, and build on top of it. Let's create it from fresh. I guess it's just easier to follow along if we do that. So let me create a second folder here. Simple app 1 is done. We understand how to test a simple application. Let's create a second folder here and call it express-app-2. And inside this, do the standard things. What are the standard things again? Initialize a project, npm init-y, and npx tsc --init. Go to the ts config that has just been created and replace root dir with /src and out dir with /dist. Then add your dependencies. Amongst the dependencies that we already had, we also have to add a few more dependencies now. Specifically, we have to add Express. We also have to add Supertest as a library. So copy this code section and just bring all the dependencies. There is one dependency that is missing here. That's @types/express. You should also add that dependency, else you'll see type errors. So after you've installed all of these dependencies, also install npm install @types/express. Now write your also initialize the jest.config.js by running npx tsjest config init. If you now open express app2, you will see it has a jest.config.js, package.json, and tsconfig. Maybe also create the source/index.ts file. All right. Now let's write our actual Express code. Simple Express server that just exposes this sum functionality. What does the code say? It says import Express from Express. Done this many times. Create an app instance from it. But notice we are now exporting this app instance because we want our tests to import it. Also notice I did not do a app.listen at the end, which is something we've been doing for a while, because we want, whenever the tests imports this library, we don't want the HTTP server to start on some port. We want the library to figure out the routes and call them directly. So whenever you're writing Express now, if you want to write tests in it, your index.ts file will not have an app.listen at the end. Harkirat, then how will I start my final application if I don't have an app.listen? I'll come to that in 2 minutes. But before that, initialize an Express application. Since this is a post endpoint that gets the body, do a app.use express.json, and then get a and b from the body, and then const answer equal to a plus b, rest.json answer, return the answer to the end user. Harkirat, how will I start this? Forget about tests. How do I start this? If I run tsc-b and node disk/index.js, nothing happens. You have not added app.listen at the end. Yes. And you shouldn't in this file. Usually, whenever a code base has tests, you will see another file here called bin.ts or binary.ts. You can name it whatever you want, main.ts, but usually it's called bin.ts, or you have a folder called bin inside which you define an index.ts. And here you import the app variable from ./index and do a app.listen 3000. What that means is this index.ts is what tests will use. Tests will never import bin.ts, but this bin.ts is what you run finally. If I run tsc-b now and node disk/bin.js, it will actually start to listen on this port. So you separate out the logic to actually start the HTTP server. If you don't do that, then whenever the tests import index.ts, this will actually start on a port. And usually when you're writing tests and you're starting tests, you don't want any resources of the machines to start. You don't want to actually start an HTTP server. You somehow want to simulate a request there. That's what I'm assuming Supertest does. Supertest might also start an HTTP server. If I had to assume though, the library actually, sends a request somehow to Express and doesn't actually start something on a port. So what have we done? We have written our code and we have also written a bin.ts file if you actually want to start the server. If I go to Postman and try to hit it on localhost 3000/sum, pass it a and a b, you will see it returns me nothing because it needs to be HTTP. And now if I send it a1 b2, it returns me 3. I have just exposed my sum functionality over an HTTP server. Question is, how do I test it? This is one way to test it. Just go to Postman. But as we mentioned already, this is not the most optimal way. These are not automated tests. How can you write automated tests if you have an Express server? Harkirat, can I start this and then, in my test.js file, whatever I'll be creating, for example, if I create a tests folder over here, inside which if I create a index.test.ts file, can I write code like this, Harkirat, axios.post and actually send a request to the HTTP server? You can do that. But why should you not do that? Because whenever you are testing, you don't know the place where the test is running. Do you have access to port 3000 there? This might be running on a GitHub machine when you run CI/CD. Maybe you don't have access to 3000. So you'd always assume, whatever machine you're running it on, you have almost minimal access there. So you don't want to actually start an HTTP server. You want to use a library that somehow reaches, this logic and is able to get back the response. And then, you can test directly on the response. Maybe that library also starts an HTTP server. I don't know. I should have Googled this before the class. But the library that we are using today, Supertest, is, the ideal way to test an Express server. Can you still start and write code like this? Okay, I'm going to write a describe block inside which I'm going to write, an it block inside which I'm going to do a axios.get. Can you still write this? You can. You can start your HTTP server and write code like this. But what do you usually do? You use a library that lets you simulate these HTTP requests. Let's see how. If you look at the tests that we have written now, which, wow, they're like a lot of them. Let's look at the tests. Don't worry about too much code here. If you look at the imports, they're still the same as the last one. We have describe, expect, and it. We had the same in the last test as well. We have the app that is imported from /index. This is why I said, okay, when you're describing index.ts, the only new thing you will notice here is we are exporting the app variable so that number one, it can be imported here in bin.ts, the thing that actually listens on port 3000. And number two, you can import it in index.test.ts so that the library that we're using, Supertest, can get access to the app variable. This library will let you, simulate sending post requests, get requests to your endpoint. So we get the app variable and we import request from Supertest. What is Supertest? If you Google this, HTTP assertions made easy via super agent maintainer. The motivation with this module is to provide a high-level abstraction for testing HTTP while still allowing you to drop down to the lower-level API provided by super agent. So it lets you test HTTP servers without writing axios.get. You can just use the API that these guys provide you to simulate sending a request. Let's see how that happens. I have the describe block. This is what I'm trying to test, a post request to /sum. And I have a bunch of test cases. Let me delete all the other test cases. Let's just focus on the very first test case over here. The test case says const res equal to await request, which comes from where? Supertest. Give it the app variable dot post /sum dot send a1 b2. Rather than doing this axios dot post /sum and sending the arguments like this, I am not using the Axios library. I am instead using request which comes from Supertest to simulate sending that request without actually starting the HTTP server. There is nothing running on localhost :3000. It is running right now, but I will stop it when I'm running the tests. So there is nothing running here on port 3000, which is why this will just break. You can either start the server and use this syntax, or ideally you should just use the request export that you get from Supertest, give it access to this app instance, which on which you have described all of your routes. So Supertest understands it's a /some request needs to go here, and then you send it a request with the right arguments, and whatever response you get back, you can sort of assert on top of it. Okay, hey, is the status code of that 200? Is the answer that I got back in the body equal to 3? That's what you expect on. You can also log console.log res and see everything that's in the final response object. If I try to run this, what's the way to run the tests? First, go to package.json and change the test scripts to have jest, and then run npm run test. And if I run it, the test succeeds. Why? Because if you look at the res object that is logged, it has a bunch of things. Pretty much looks like the exact response object you get from jest, which gives me a hint that this might actually be starting a server. But if you look at the body, somewhere here, you'll figure out, yes, it has, whatever, answer :3, which is what we're asserting on over here. Res.body.answer should be 3. What if the developer makes a mistake and, rather than doing a plus B, does a into B? The test will begin to fail, because now you will get back 2, because 1 into 2 is equal to 2. And since your logic is broken now, your tests were able to tell that in an automated fashion. You did not have to go to Postman, send a request, and then figure out that 3 is not equal to 2, so there is a bug. That is why you write tests, and this is how you write tests using the Supertest library that lets you send requests to an Express server and assert on the response that you got back. Do we understand this Supertest library and how to use it in our tests? How to test HTTP servers? Given you know this, you can already start to test HTTP servers. It won't work because real HTTP servers connect to a database, which is a whole different problem. We'll come to in the next slide. But 84% understand. Looking at Q&A for 2 minutes, and then we will proceed to the slightly more difficult bit of adding a database. But anything specific? Can there be loops and conditional statement inside expect? Yes. You can assert on multiple things. You can be like, as long as a single expect fails, the test will fail. So if you have a loop inside, that is fine. If one of them fails, you're good. Question 1, can you share a practical test case in which testing would be great to have? Practical test case, any website, every endpoint should be tested, right? So practically if you have a website, for example, daily code website, every endpoint there should be tested. Why can't we start the server index instead of, why can't we start the server index.ts? Because if I do app.listen 3000 directly here, then if I run the tests will actually start the server on 3000. That is mostly fine. But what if I run the tests in 2 terminals? Then the second terminal will not be able to do app.start. So if I try to rerun npm run test in another terminal, as you can see, 2- it fails. Why does it fail? Because it says I cannot listen on port 3000. So if you have tests running, you don't want them to take up a port, which is why you move that logic to a separate file. Supertest does use a port, it seems. So it does start an HTTP server, only it probably starts it at a random port, which is why you can do it on 2 separate servers. Then uses a server to make a request. So it does actually create a server under the hood, which is fine. As long as it's on a different port, it's on a random port every time, you will not see the port conflict error. Let's say we are testing a functionality, but let's say that writing the test files by mistake, the test itself is wrong. Then, screw your developer. What if your logic itself is wrong? It is wrong. You figure out the bug eventually at runtime, and then you fix it. Of course, if the test itself is wrong, then, or you could have a flaky test, right? If I would have done this, sum of 0, if my test case looked something like this, 0 and 0, okay, sum of 0 and 0, expect it to be 0. Then it doesn't matter if the /sum endpoint adds, multiplies, or subtracts. If you have a flaky test, then also it's a problem. So You don't write bad tests, and if you do, you will eventually catch the error at runtime and then fix your tests. Slides are not working. A few people are saying this. Let me testing -1. Why are they working for me? Let me paste the code one more time. Refresh. You will not find them on daily code. I think there is some bug we need to fix. Most probably, we have hit the limit that's going to Prisma, which is why it's not present on the landing page. But if you go to the link in the chat, it should work. Let me quickly do a poll and then we'll proceed to slide number 4, I think. Slightly more complex endpoint. Oh, okay. This is actually pretty simple. Poll. Can you guys, do the slides work for you? Yes or no? I would assume the answer is yes. Oh, they don't work for a lot of people. Whoopsie daisy. That's a 50-50 right there. Why would the slides not work? Hold on. Have you guys logged in? Maybe it's that. Just try logging in. Oh yeah, try logging in. That's my bad. Oh yeah, I think the latest code is there. So yeah, just log into the website. Go to project100xfs.com, and then there's a button over here. Log into the website, and then you should be good to go. All right, cool. Let's move on to slide number 4. Oh, it's 7:50. Oh, it's an hour already. Wow. Let's take a break of 5 minutes. We'll restart at 8. We've only reached slide 4, which is not great. But yeah, until then, please figure out, log in. Hopefully that works for you. Let me open chat and answer a few questions. Until then, we'll restart at 8 p.m. Alrighty, a lot of them. Alrighty, can't log in. Login is also not working. Oopsie daisy. Alright, if we do some live testing then. Alright. So Nimit created a PR. We wanted to create a PR that, lets you forces people to log in. But I think there's a bug. So basically there's a bug in prod right now. I just have to revert to a specific code base and then, a specific checkpoint and then rebuild. And I think that should just fix it for everyone. Can't log in, okay, yeah. God. This one, let's do a get answering questions. Can you please provide some sort of an assignment for project to brush up the skills related to WebRTC and gRPC? Akash, are you on the call? Create a note of that. Yes, we should do one for. There were assignments on WebRTC, but I don't have solutions basically. But there were 3 assignments at the end. gRPC assignment. Alrighty. Revert to the commit with Sujit. Alright, let's see. Git log. I have to revert right before Nimit. Okay, this is the one that I need to. Yeah, exactly. So I think this one should be fine. Do we also want to know about database scaling, partitioning, sharding, other functions? We should do sharding, partitioning, database scaling. Yeah, we should probably do that. Sharding, partitioning, and scaling. We should definitely cover that. Sharding was actually part of the database video, but I think I skipped it. But yeah, when I cover that, I'll probably cover these 2 as well. Akash, make a note of that as well. Alrighty, let's see. Should probably do it. Let's see. Open a fresh tab. Alright, there we go. I think it should be fixed now. 2 more minutes. Let me answer a few questions. Yesterday's doubts, let me come to them at the end of the class. Also, just feel free to send me on WhatsApp. ETH also, okay. Unrelated. You said it's grab out port being used error. Most libraries have port warning and start on a different port. Like if, yeah, Next.js will start on a different port. Yeah, but okay. What is the benefit of using Supertest over just doing it yourself and using Axios as a library? Number 1, well, that's not really a good number. Okay. here is a thought experiment for you. You said if you have Next.js, it will automatically start on a different server. Yes, if I have app.listen here, and if it doesn't start on 3000, it will probably start on 3001. But what will you write in your tests? Will you write, axios.get? You'll have some sort of a port hard coded here, right? I'm just trying to solve find problems in using Axios directly rather than using Supertest. Yes, you can do it without Supertest. You can start your HTTP server and it will still work. But what are the problems you might run into? Port conflicts. If your process does run on different port, then you need that specific port to come here as well. So you have to worry about all of these things. Versus if you use a library like this, it automatically is doing the logic of starting it on different ports every time and sending a request there. All right, I would assume the slides are working now, but let me not assume and just relaunch a poll. We will fix this in today's YouTube live. We have to fix all the projects that are broken on master, but seems like it's working now, sort of 90%. I would assume bad internet for 10%. Alrighty, 8 p.m. We have a few slides to go through. We can skip this one actually. Let me give a brief of what this does. In this slide, I actually wanted to just show how can I, let's say, if this, rather than taking A from the body, it took it from, let's say, the headers, then how can you send headers over here? Rather than, this is how you send body, but how do you send headers in a request object using Supertest? So I wanted to show all the ways, or how do you send headers, how do you send query parameters, things like these, but fairly easily Googleable. One more thing I wanted to do here was introduce Zod. So let me quickly show you what was the goal of this specific slide. Let me introduce Zod to our code base and make our endpoint a little more strict. You don't have to follow along. There is the code that you can look at. But if I add Zod and if I change the endpoint to be something like this, okay, rather than assuming that whatever the user is sending is right, we actually use Zod to parse the end user input. If you remember what was Zod used for, we use Zod to do input validation, input sanitization. Okay, the user sent us rec.body, but we don't know if they sent us two numbers. Maybe they sent us something random, and we should handle this case explicitly. If they did send us something random, then we should return them an output that says incorrect inputs or something like that. If that's not the case though, then it's fine. You can take the answer and return it back to the user. That is what this code base does. Now we have two paths. We have this if path. Here, if the user did not send us the right thing, then this should be returned. Else, this code should be returned. Harkirat, where is the else? Even if you don't write else here, it is fine, right? This is called early returning. If I return early, that means the code execution will stop right here, which means only if we don't go inside if does the control reach here, which means it's equivalent to me putting an else over here. I can put an else and do this, but I don't really need the else, because if I return over here itself, then if it goes inside the if, code execution would stop, which means everything after that only runs if this did not succeed, which is why you don't need an else. What is this called? This is called early returning, just a pattern that you follow in JavaScript. I get the answer. Harkirat, why did you not get the answer like this? rec.body.a. What are you doing over here? This is just a better way to get the inputs, because we've already done the validation over here. We have defined a Zod object. Okay, this is what my final input from the end user should look like. It should have a argument, which should be a number, a B argument, which should be a number. If they send something else, this specific passed response would return success equal to false. And if that is the case, then you return right here. If that is not the case, if everything is fine, then if you use the passed response.data, you just get better types. If I do a passed response.data dot, I see A and B over here. Versus if I do a rec.body dot, the type of body is any, you don't get good types, which is why I've used passed response here. You can also use rec.body.a and rec.body.b, either is fine. Now if I start this project, if I do tsc-b and then node bin dist/bin.js, if I send the wrong inputs, if I send an array here, Now I will get back incorrect inputs. Before, I would get back something weird. It would still return me something because I had no input validation. If I remove the input validation from here, if I remove these two lines and simply return answer rec.body.a plus rec.body.b like we were doing before. Now if I run node dist/bin.js and send these bad inputs, I get back something. I get 1, 1, 2, 3 back, which is wrong. And hence, I've added input validation, something you should do irrespective of whether or not you have tests. But now you have two paths to test. Your coverage will become much lesser. What does coverage mean? It means how many lines of code your tests have covered. Our test right now gives the right input, 0 and 0. And hence, it will cover this line of code. It will cover these lines of code. It will not cover these lines of code. So our coverage will not be 100%. Hence, we should add another test which takes this hot path. We should add another test that says, here I'm going to send bad inputs. A is going to be a string or an array of a string. And I'm not even sending B, let's say. I'm sending extremely bad inputs. Now, I would expect rest.status to be what? What status I was returning here? 411. If the response is not right, then the status being returned is 411. That is the status I should expect here. And I should expect a rest.body.message. If you remember, I'm returning incorrect inputs as the message. That is what I should put over here. Now we have two tests and we have complete coverage of this specific endpoint. What does coverage mean? It means when my tests run, there is one test that tests this path. There is another test that tests this path. And hence, all the branches of this specific handler have been covered. That's a good thing. You should add more such test cases to cover as much of your code as you can. If I run the test again, npm run test, both the tests succeed. It says 2 passed, and hence, basically means both of them are working as expected. And yeah, that's pretty much what I wanted to share in this slide. How you don't only check for, success cases, you also check for unsuccessful cases, and you should add tests for them as well. Given that we have done that, the other thing I wanted to show was, what if the input that was expected was in the headers rather than the body? What if we created another endpoint, which was a get endpoint, and hence you can't take input in the body. There is no body that exists in get endpoints, and hence you have to take it either as a query parameter or as a header. In case you do take it as a header, how can you send a header using supertest? And the answer is, if you look at the second describe that I created here, when I'm sending await request app dot get /sum dot set is what you can use to set headers. In this case, I set two headers, A and B, and I expect the status code to be 200 and the answer to be 3. But if I don't set any headers, here I've not done a dot set, and hence I expect the status code to be 411. If you look at the code, even on this get endpoint, I first check whether or not the inputs are right, and if they are not, return a 411. If they are, then create the sum and return that. Do we understand this? This slide just covered something extra that you should do, but like nothing too much extra from the next slide. And hoping this was straightforward, but let's see. All right, good enough. 87%, pretty good. If we understand this, now comes the most difficult use case. The thing is, until now, we don't have a database, but most big applications will have databases, right? So if you're creating a full stack application, if you have an HTTP server, you will have a database. And just how I avoided doing a app.listen, I did not want to start the HTTP server locally. Similarly, you avoid doing database calls when you're writing unit tests. There are actually 3 types of testings that you can do. There is unit testing, which as the name suggests, you test a small unit of your code. You don't start/connect to databases here. There is integration testing where you do connect to databases. And then there is end-to-end testing, which is something you do when you have front ends as well. And you actually start a browser while testing. Right now, we're doing unit testing, which means we need to just test a unit. And specifically, what does unit mean? It basically means, if this is the code that you're running, you want to test this logic. If there was a database call here, await db.create something, you don't want to test this. You can assume this does the right thing. That is what a unit test says. Unit test says, kya database call will succeed? Ignore it. Somehow ignore this line of code. And then, test this logic, of course, ki the input is right. Test this logic, of course, ki the sum is done correctly. But, you don't have to worry about testing, putting something in the database. You don't even have to start a database. So if I was logging all of these requests in a database, I would have had to ignore or mock out this specific call. I would have to mock. What does mocking mean? Okay, this should not actually happen. It should just succeed. This function should somehow succeed, and then you should move to the next line of code. How can you add mocking to your code base now, given you are able to write simple tests, but now that we're introducing a database, how can you mock the database requests is what we have to discuss next. You can do mocking in Jest as well, but VTest makes it a little easier. In fact, it's fairly similar. It's not, VTest doesn't make it very simpler / easier. It's just easier to do it with Prisma, which is why we're moving over from Jest to VTest. VTest is also a testing framework. It's highly backward compatible with Jest, which basically means after we move from Jest to VTest, we don't have to do much. All we have to do is replace this with VTest. Everything else will just work. It's highly backward compatible with Jest. So it's written in a way that if someone has written their tests in Jest and they want to move over to VTest, they should be able to do that fairly easily, which is why this transition shouldn't take us a lot of time. Let's move to the next slide and let's start a simple Express project with VTest. Basically, the same thing that we have right now, but let's try to replace Jest with another testing framework. What is the testing framework? VTest. Let's start from the top, I think, and do everything together. Does this slide cover anything extra? No, it covers the same thing as slide number 4 or 3, I guess, whichever one. But the testing is done in VTest. Very simple, very straightforward, shouldn't take a lot of time. Let's start from the top. Let's create a third folder here called VTest testing 3. Now steps remain the same again. Initialize an empty project. Only rather than installing Jest as the testing framework, we will be installing VTest as the testing framework. Everything else remains the same. So npm, let me just copy these actually. Install all of your dependencies. After you do, replace tsconfig.json rootdir with /src and then outdir with /dist. Create source /index.ts file. If you look at the code, it's still exactly the same as the last slide, where we have a Zod object, a post endpoint, and a get endpoint, which pretty much, check the same thing. First, they check is the response correct. If it isn't, return a 411, else they return the actual answer. The code is exactly the same as the last slide. The thing that is being changed is the testing library. How do you bring VTest in your Express server? npm install VTest. Bring the dependency locally or bring the library locally. And then as simple as this, rather than, you can pretty much copy the existing code or the existing tests. So create a new file folder called tests, create a new file called index.ts or index.test.ts, and copy the tests from the last slide. They will just work. Only thing is, rather than importing from @jest/globals, you should import from VTest. That's all you have to change. Highly backward compatible. I also have to install supertest and @types/supertest, and in package.json rather than writing just over here, I have to type vtest. All of these steps are here in the slides as well. Now if I, oopsie daisy, what the fuck happened here? Now if I run npm run test, you will notice tests are passing. The two tests that I just added, and now rather than using at jest/globals here, I'm using vtest. Everything else is exactly the same. It's just, you know, another library to do testing. Why did we use this? Makes mocking slightly easier. That's the only reason. Do we understand this? Do we understand how we moved from jest over to vtest? We moved a little quickly, but if you look at the slides, the only thing we have changed is, you know, in our express code, we have written our express code exactly the same. We've written our test exactly the same. Rather than importing these from at jest/globals, I've imported these from vtest. Everything else is exactly the same. And rather than, of course, bringing in the jest libraries, I brought in the vtest library as a dependency. If you look at the final tests, they should run. You know, yeah, just another library to do. Is there another third library? Yes, there's another library called Mocha that lets you do testing. So, you know, you can pick and choose which one you want to do. Constructs remain very similar. All of them are written, you know, similarly. So you can move from one to another. But, you know, my guess is vtest is what people will eventually resort to. Has like everything you need for both front end and back end. Are we good to go? Do we understand how to move from jest to vtest? We do. Alrighty. Then the next steps are actually mocking. Adding a database. If I ask you now, here every request that is coming, please start logging every request in a database. How will you do that? You will first bring Prisma as a dependency in your code base, right? Or if you use the PG library, use the Mongoose library, steps remain the same. Prisma is the one we're most comfortable with, but you know, you can use any library of your choice. For connecting to a database, you can use a different ORM. How to mock remains the same irrespective of what ORM, ODM, whatever you're using. There are two approaches to take when you bring an external service to your backend. What is an external service? A database is an external service. It's a process running other than your main Node.js process. You can either mock out your external service. These are called unit tests. Or you can start every other service. You can start a database and, you know, actually connect to a database, actually put some data in there, which is usually called integration tests, or even end-to-end tests need to do the same thing. We are focusing on unit tests, which is why we will mock out all the external services. That includes, you know, Prisma basically. If you ever try to do a prisma.user.create, that will be mocked out. What does mocking mean? We'll come to very soon. Let's bring Prisma to our code base now. If you remember, again, this final code will be present somewhere. It's probably the fourth one here. So if you go to the GitHub, you'll find the final code over here. 5 express vtest Prisma. We're pretty much reaching the end. So if you don't want to write it, you can just look at this code. If you want to write it, then I'm just building on top of the existing code that we had. In our existing code, let's quickly go through what our existing code looks like. Our existing code has 2 files of interest. File number 1 is source/index.ts, which has some Zord logic over here, 2 endpoints, an app.post/sum and an app.get/sum. This is what our main core logic looks like. And now we want to add some database logic in here. We want to actually store in a database whenever the sum endpoint is invoked. And hence, we're going to bring Prisma to our code base first. What is the way to do that? npm install Prisma, npx Prisma init. So 2 commands I ran: npm install Prisma, npx Prisma init. This will initialize a Prisma folder inside which I can begin to add my schema. My schema, thankfully, is fairly simple. I have a single table called sum, which will store 4 things: the ID of the thing that's being stored, A, which was the first variable that the user was trying to give, second variable, and the final result. I want to store all 4 of these in my database. I've written the model. Now, should I start a database? Ideally, yes. If you want to create a real world application, of course, you will have to start the database, migrate the database. But we are not testing this by hand. We will not open Postman and click on test. We don't need a database. We are trying to mock out a database, and hence you don't have to worry about migrating it just yet. You don't have to worry about what URL is present here. You can have a dummy URL. It doesn't matter. We are not going to hit the actual database. Our tests will mock out the database calls, and hence all you have to do is npx Prisma generate, which, if you remember, generates the Prisma client. What is the Prisma client? The thing that lets you do prisma.user.create or prisma.sum.create in this case. So generate the client, but you don't have to migrate the database. You don't have to run the other command that we used to run, which was this. You don't have to run this. You do have to generate the client. What does this command do? If you remember, it creates the node modules /@prisma /client, this specific library that you finally import in your code base. So what have we done? We have now initialized Prisma in our code base. What do we have to do? We just have to add a database call here. Whenever you are returning the user something, you should also do a db.sum.create data a, b, result. Something like this. The question is, where should this db variable be? If you remember, until now we have done this. Let me just put const Prisma client equal to new Prisma client globally. I just import it over here and then I use it here as well. A would be whatever, let me just hard code a value here for now. This is how we've used the Prisma client. But when you are mocking things, right? In this case, I want to, if you remember, I said, we will mock out this request. We want this request doesn't actually run. Whenever this code is being tested, we want to run a unit test. A unit test means run all of this code, run this code. This to bhaiya should get mocked out. What does mocking out mean? This should not run anything. It should just run an empty function basically. Somehow we want this call to be replaced by an empty function call. How can you do that? The answer is you create mocks. And when you're creating mocks, you don't usually, whatever you're mocking out is usually present in a separate file. You can probably, keep it here and still mock it out, but it's easier if you create a separate file, let's say db.ts, inside which, you export the Prisma client. So create a separate file called db.ts inside which we are exporting the Prisma client, and then import it over here rather than redefining it. Something like this basically. Logic is still the same. Nothing has changed. But now we can tell just, please mock this specific file completely. Whoever is trying to run this file, this should not actually call prisma.sum.create. It should do something else. So what have we done? We introduced some database logic in our code base. We added Prisma as the ORM. We defined some basic schema for a model. And now we've written the code to actually store the input in a database. Let me store the right input here as well. This will be answer. This will be past response.data.a. This will be this. This code should just work. If I start this, then it will actually start to populate the database. We have not connected the database. We don't have a database, which is why it will not work. But if I do bring a database and start the application, it should just work. How do we create the test for this? If I go to index.test.ts, if you remember, I said we need to mock out a specific library. We need to tell it, if Prisma client, whoever is importing, right? Whoever is importing this db.ts, they should not get back a Prisma client. They should get back something like this. Const Prisma client 2 equal to sum create empty function. This is what we want this to return. Whenever a test is running, if someone calls Prisma client.sum.create, ignore the arguments, don't do anything. Don't actually send something to the database. Create a mock that looks like this. How can you do that in vtest? And the answer is, firstly, do we understand this? We want when the test runs, this file doesn't export this. We want this file should export something like this, which is a completely empty skeleton of the functions that we'll be calling. If you remember, what are we calling in index.ts? We are calling client.sum.create. So what do we want? We want .sum.create should be an empty function, should not do anything. That's what we're trying to do. Let's see, how can you do that? How can you mock out this request? The answer is, since this is such a popular use case, you can do it in one line, which I totally forgot. What is that line? The line looks something like this: v.mock. Oh, yeah, looks right. Firstly, import v from the vtest library. This variable sort of is what you use whenever you want to mock or do other things like spying. And then add this line of code. Here ./db should export this new Prisma client. Sum create v.fn. Harkirat, why did you not write an empty function here? You can probably write an empty function, but general practice is you use v.fn, which also is an empty function. I think the reason you might want to use it is because if you use v.fn here, you can actually spy on the requests that are coming. So what have we done? We said here ./db, don't export this. Export something like this. What did I say? Let's copy this here and bring it here. Export this file should export Prisma client. If you remember, export const Prisma client. We're not returning, this file isn't exporting a default, it's exporting a constant called Prisma client. This file can export multiple things: Prisma client 2, Prisma client 3. We want the Prisma client that this is exporting, which is, this thing right here, should be an object which has a key called sum, which should be an object which has a key called create, which should be v.fn, which should be a mocked out function. What is v.fn? An empty function that does nothing. If I write this much code base at the top of my file, then this request will get mocked throughout. Basically means whenever Prisma client.sum.create will get called now, this will reach this mock, this create function, which pretty much does nothing. That is how you introduce mocks in a most simplest way. There are complex things you can do, which we'll get to, but this is the most simplest way to create a mock. If I go to the terminal and run npm run test, you will see both the tests succeed. If I remove the mock though, you will see the first set of tests are stuck. Or I only have 2 tests, so both of them are stuck. Why are they stuck? Because what do they say? What does the answer say? Test timed down 5000 milliseconds. It said here for 5000 milliseconds your test did not return, so I timed it out. Why did it get timed out? Because Prisma client.sum.create invocation failed. Prisma client initialization error. Basically this create call threw an error. Why? Because we don't have a database currently running on that specific port, which is why this will fail unless you mock out its implementation by doing this much. This is all you have to do to mock the implementation of Prisma client. Harkirat, what if someone else uses prisma.sum.find1? Then you will have to make this mock more complex. There are other ways to fix this, which we'll come to in the next slide. But if you know someone else is using find many, then just add another mock here. Harkirat, what if there is another table? Then add another table here. Users table, which will have a create function, which can be v.mock. So you can make this mock very complex yourself, or there are fancier ways to fix this, which we'll come to in the next slide. But do we understand mocking? And why is it needed? Same logic you can apply to if you ever are connecting to Redis, or are connecting to Kafka, or are connecting to another external service. Sort of understand it. 79%. Let me open Q&A now. Explain /db. What do you want to mock? Currently I am in test/index.ts. Which file do I want to mock? db.ts. So dot, which means go from the tests folder to the source folder, /db.ts. This is the file that I want to mock. That is what /db means. What do I want this file to return? I want this, okay, this might seem like extremely complex syntax, but it basically means something like this. Okay, this should be mocked, and the second argument is a function which returns the final thing, which is the mocked out thing that you want exported from here. What do we want exported? A Prisma client variable, which has, some which looks like this. That's all you need. So let me just get rid of everything else. Something like this. You don't even need this. There you go. That's a slightly cleaner way to write the same thing. There we go. There will be an offline class for this. There's a lot to cover after this. So yes, there will be an offline class. Why do we need to mock it? If you don't mock it, then you're writing an integration test. What is an integration test? KR, I will test everything, including putting data in the database. The problem there is a lot of times, okay, if I, what's the best way to put, why should you use unit tests over integration tests? Because a lot of times you just assume that the database will do the right thing only. The thing I want to test is this logic. Am I checking the responses, the inputs correctly? Am I returning the answer correctly? You don't want to check. You assume the database does its thing correctly when you're writing unit tests. You don't do that in integration tests. Then you test everything. But unit tests are supposed to just cover all the lines of code that are not dependent on external services. This part is dependent on an external service, which we just assume works, and hence we just mock out this function call. Can we simply write Prisma client object with all the Prisma functions in v.fn? Mock out the Prisma function that we use. We can do something similar, which will come to in the next slide. You don't have to, know all the keys over here and write them like this. There is an easier way to, tell vtest, please mock this whole object, and it will do it. We'll come to that in the next slide. If our goal is to mock, then why are we even defining Prisma? We are defining Prisma because eventually this is a real world full stack application. We want in that full stack application to store data in the database. The tests are mocking it. The real application isn't mocking anything. If I go to bin that we had created here, maybe we haven't here. If I create a bin.ts that actually, imports app from ./index and then does a app.listen, here no mocking would happen. You would actually hit the database. It is only in the tests that you want to mock out the database calls, or do this. Sir, can we can we create random tests using for loops or something? You can do that. You can do that. You don't do that. You don't do that usually. Your tests are very deterministic. You should never have random tests. You should never try to randomize tests. Just rule of thumb, or good practice. So, sir, we need to make empty skeleton for every DB API. You don't need to. We'll come to that in the next slide. You can tell Prisma, vtest here. This is what the Prisma object looks like. Please mock out the whole thing. It will mock out the whole thing. So you don't have to do this. It's just the easier way to understand. For at the moment, we'll fix this in the next slide. Can you explain how npm run jest tested the route even when the local server is not running? There is a server running. That's what someone mentioned. Whenever you use supertest, whenever you're using this library and you do a request of app, it does start a server. And there is a request that goes out. Only that server starting is offloaded to this library. And you don't have to separately start something on port 3000. How do we mock Redis DB requests over here? Similarly, right? Just like I created db.ts, you will create a separate file called redis.ts. You will export Redis const Redis client equal to whatever new Redis, and then you will mock out this specific file here as well. Okay, v.mock /redis, and then whatever you want Redis to do, or to be mocked out as. So that's how you will mock out every external service that you have. You will define every external service, or you will initialize every external service in a separate file. But the TypeScript, the test file will run after it will convert. TypeScript never executes. If you have a TypeScript file, it cannot run. There is no runtime for TypeScript. There is only JavaScript runtime. So always the answer is yes. You never run TypeScript code. You run it. It is getting converted to JavaScript, and that's what's running. Is there a similar to how Foundry does testing using Forge test? That is Solidity testing. It is similar, but it's separate language. Is it similar to how Java does testing? No, sort of. They have similar concepts of mocking, concept of asserting, but libraries are different. Is this valid for Drizzle as well? Yes. If you use Drizzle, just define your Drizzle object in a separate file and then use it and mock it. So it's exactly like Mockito in java.junit, exactly. All right, we're taking a break only. Anyways, I think we won't be able to cover the whole thing, so I'll probably cover everything else in an offline video. The things that are left include deep mocking, which is something someone was asking, how do you, maybe let's cover this much today, and these I will cover in an offline video, but let's do it after a break. How are we doing though? Do we understand it slightly better now? Specifically the mocking bit. It is similar to Mockito in Java. That library also lets you do, okay, we do understand it fairly well. Let's take a 2-minute breather, and then we'll understand deep mocking, and then we'll call it here. The last 3 slides, which are spies and adding it to your CI/CD pipeline, which fairly straightforward stuff actually. If you understand until here, then spies should be straightforward, but I'll of course cover it in an offline video. Maybe I'll do the offline video from scratch. All right, look at Q&A for another minute, and then I will explain this. Repeat mocking once. Yes. Okay, here is a statement, or it's already here. Whenever you are writing unit tests, you don't start or connect to a database. You don't connect to Redis. You mock them out. What does mocking mean? Number one, mocking means when you mock someone. Okay, you are scolding them. This is not that. Mocking also means you are trying to fake something. You are trying to fake connecting to a database. That is exactly what we want. We want to fake connecting to the database so that whenever you are writing unit tests, they don't actually hit your database. These tests will run left, right, and center every day. If a developer is running an npm run test, you don't want the production database to get a new entry, right? In fact, you also might want that developer doesn't need to start a database. For the developer, thing just runs. And hence, you mock out all external services like databases. How do you do that? Number one, whatever external service you are using, you initialize and export it from a separate file. For example, here the Prisma client is being exported from a separate file called db.ts. And once you export this, you import this normally in your index.ts. Here you do no mocking logic, nothing like that. You write it like you would usually. But in your tests, at the top of your test, you say, I want to mock this specific file /db, and I want the file to return this. Rather than returning the Prisma client I don't want it to return this. I want Prisma client to be an object which has a sum key, which is an object which has a create key, which is v.fn. That is what mocking means. The problem with this mocking though is, we are now moving to the next section. Let me complete today's slides, or at least what we're supposed to cover. Problem is, as your object becomes bigger and bigger, you will have to add other things. If you added a user object, then you have to create user and keep on making this object more and more complex. Thankfully, vtest lets you do something called deep mocking, which basically means another way to mock variables is to let vtest figure out the types of and mock out all the attributes for you. What you can do is, if you do a console.log of the Prisma client, right, or all the keys of the Prisma client, you will see a lot of them. Sum is one of the keys, but it has a bunch of other keys. If in the future I add another table called users, you will see user as a key here as well. What if you could just tell vtest, please mock the whole thing. If as nested keys, jitni bhi keys hai, please mock them, all of them out. So you don't have to, yourself define this object. You can do that. How do you do that? You have to use this other dependency that they provide called vtest mock extended. It lets you mock recursively all the functions they have. They have a user.create.find.find1. It will mock out everything until the end. So first you install this library. I will again recover this in the offline video. So if you don't understand, it's mostly fine. And then another common practice that you will find not just in VTest but in other frameworks as well is that you create a __mocks __ folder. What is this folder? Here, if you ever want to mock db.ts, right, you will create a __mocks __ folder in the same folder as db.ts is. If db.ts was, in a utils /db/ index.ts folder, then you would create __ mocks here. You create it right next to the file that you want to mock. Since we want to mock db.ts, I create __ mocks /db.ts file. This means I'm defining the mock for this main file. This is the main file, and I want the mock of this, the dummy implementation of this, to be defined over here. And here, if you look at it, ideally you would have done this. Here I want to mock /db, and I want to do sorry, this is wrong. This is the code that you have to write. There you go. What do? We say, yaar, this will export by default. Prisma. Hold on. Oh, this probably I probably exported Prisma client here by default as well. No, it was a const. Sorry about that. What I was saying was, where did it go? Sorry, which slide was this? There you go, deep mocking. We say this file will export Prisma by default, which doesn't look right if I'm being honest. I would have expected this to be a const. Something like this. This looks right. I think this is right. We will see. We say here Prisma client, the mocked Prisma client, you can either do this. You can totally do this. Okay, some create and then v.fn. You can do this, or you can use the library that we just imported, which lets you deep mock a Prisma client. Okay, rather than creating a new Prisma client and exporting it, I want to mock it deeply. What does deeply mean? Okay, this will have a sum key, which will have a create key. I want that to be mocked. If this has a user key in the future, which has a find one key, I want that to be mocked. I want every transitive key to be mocked to the very end. That is what mock deep over here means. I want the Prisma client class. I don't want to create a new instance of it. I want this to be mocked as deep as possible. You export this, and then rather than doing this complicated thing, you can simply do this. v.mock /db. It will understand that you want to pick up this specific mock. If you don't do this, then it will not pick up the mock that you have created. You have to tell it, I want to mock /db, and it will understand, I will pick it from here. And here, what have we done? We've exported a Prisma client, which is a deep mock of the real Prisma client over here. I will re-explain this if this was a little too fast. Let me just quickly show that it does work. And if I over here log, if you try to log Prisma client here, right, or even in index.ts is when you'll see maybe something that explains things better. Prisma client. If I log the Prisma client here in index.ts and rerun the tests, you will notice it's some mocked object not keys. I would have expected slightly more detail here. Import Prisma client Prisma client from dot dot slash db. Huh. I would have expected this to give more detail, but okay. I will debug this later. And you know this, I would have expected this to give a lot more keys basically. It just returns is mocked object to be true. That just looks wrong. But you know, maybe I'm missing something. Either way, yeah, that's a brief. Maybe you can log. Let's try logging this Prisma client dot sum. Yeah, exactly. There you go. So if you look at it, Prisma client dot sum now is this very big function, which you know is again a mocked thingy. If I do a dot sum dot create, that if I log that, that also is a very big mocked thingy. Every key of mine has been mocked automatically. I did not have to write, you know, whatever we were writing before, which was, you know, a deep object ourselves. That is what deep mocking lets you do. What did we actually do? We wrote this file right here. We said, here the thing that's being exported is a deep mock of Prisma client, rather than, you know, doing, if I go to underscore, rather than doing export const Prisma client equal to sum create v.fn. I can do this as well. This will also work. But you know, this, I will have to keep re-updating this object every time more keys are added. So rather than exporting this mock, what do I export? I export a mock deep, which comes from this library of the Prisma client. Harkiyat, why did you do capital Prisma client? Why did you not do small Prisma client? Because I want to mock an object of this class. That is what mock deep of capital P Prisma client means. Here, create an object and all the keys that are there, mock all of them out. That's what this mock deep lets you do. And you know, that's how I no longer have to define this myself. All of the keys of this class have been mocked out. Did we understand this? If not, that is fine. I will cover this in an offline video as well. I'll probably cover everything in an offline video. Like we'll probably go from the top. You'll sort of understand it. All right. 76%, 80%. Alrighty. Let's call it here, guys. As I said, the things that are left to cover actually is, yeah, spying and mocking return values. I'll cover it in an offline video. It actually, there are details here. Basically, you can read through them yourself also, but I will cover it in an offline video. Then there is spies. Then there is how do you create a CI/CD pipeline for it, which actually is fairly simple. You know, you create a pipeline which runs npm run test. If it fails, you know the PR has not succeeded. If it doesn't, then you know the PR has succeeded. I created 2 PRs before the class. One of them is successful, one of them isn't. That's pretty much it. Then I cover a little bit about what are unit tests, which are the thing that we've done today. And then integration tests, which is something I'll probably cover in an offline video. And end-to-end tests, we probably won't do this, but I'll share the libraries. Like Cypress is a popular library that lets you do end-to-end tests. In fact, my GSOC video on YouTube, the most recent one where I was contributing for 3 hours, is also in a library that lets you do end-to-end tests. But I will pause here and open chat and we'll go from there. Bunch of questions. All right, let's take a pause. Issues with testing. Another Notion doc. Next class on, probably on testing or Kafka. We need to finish testing in Kafka, then we can move to DevOps. And maybe someone mentioned database concepts today, so that as well. But that can probably be an offline video. Okay, bunch of Notion docs. Fixed login on daily code. We'll look at that. Start from the top. We usually seed a Docker database and test endpoints against that. Does that mean we do integration testing, or we do integration testing in that case? If you are seeding a Docker database and testing against a database that has been started in Docker, then yes, you are doing an integration test. How to mock AWS service for integration testing? Ooh, that is a good question. You cannot start an AWS service locally, right? Yeah, you would mock it out. You can create a test S3 bucket, let's say, and then, store all of your testing data there. I don't think that's standard practice. You should assume whenever you're running a test, your machine has no internet. So, if there is an AWS service it has to hit, either you have to create, if there is S3 that you were trying to hit, there might be an open source not an open source S3, but an open source thing that at least has a similar API to S3 that you can hit. But if you are literally hitting a closed source service like AWS, you cannot do an integration test. You can do it if you want, but it just sounds like a bad idea. You will have to mock it out. There's nothing else you can do. Also, with respect to yesterday's class, what is the format of data transferred from database to application? That is still the same. If you're using whatever that is, if you're transferring data from your Node.js process to Postgres, whatever that format is, probably you're sending an SQL query, so it is SQL. You don't change that when you're using gRPC. It is none of JSON, XML, and Proto, right? You run an SQL query and that's what you send to a database, right? From a Node.js process or otherwise. So that's, now does an SQL get compressed? Probably, I don't know, maybe, but it's not JSON, XML, or Proto. And introducing Proto or gRPC has nothing to do with the data being transferred between the database and the application. It's between two applications that the data is transferred via protobufs. So even on our application is a gRPC server, as long as the data transfer from database is not in Proto, we are not reaping the benefits of compression. We are not reaping the benefits of compression in that case. Yes. Thanks. Alrighty. How can you do it? Can you compress data before going to SQL? Is that even a problem at scale? Probably there is a solution for this that I don't know of. When you're sending data to a database, you compress it. Getting data from a database, you get it in compressed format. But yeah, gRPC won't give you that solution. I did do that, Sama. Off topic, update on progress. Made a multi-chain deployable smart contract on Ethereum using Foundry. What's a multi-chain deployable? I'm assuming that's EVM only. We should talk, Ishan. How lead code tests? What do you mean multi-chain? Do you mean a bunch of EVM chains you deployed on? Or do you mean something else? How lead code test cases? Do they use vtest? No. Whole different architecture. This is for testing your own thing. They might use just some libraries or some online IDEs I've seen use just for testing JavaScript test cases, but usually you do something else. You can use just for JavaScript, but you cannot use it for C++, right? So there's a more generic way to solve than using testing frameworks. A lot of times I've seen just being used as well, by the way. Unit tests are forcing us to keep the code modular, if I'm right. Yes, exactly. I wouldn't say modular. They're just letting you catch. Not really. Like, how are they forcing you to keep the code modular? They are forcing you to keep the code correct. You can still write it in a very ugly fashion. It's just testing the functionality. So it's making your code more correct. It's not necessarily making it more modular. Okay, you're saying we had to push it to a different file. That's why probably, yeah, you could say that. If you're mocking out, that means you're putting things in separate files, which is making it more modular. You can say that. Alrighty. Yesterday, I tried to find some recently funded startups. I found most of them don't hire remotely outside US. How you guys find remote startups? You will have to ask the people who find them. But how do you know all of them don't hire outside US? Have you tried contacting them? A lot of companies, I don't know. How did you figure that out? Basically is my question for you first. A lot of times companies will have this on their page. Doesn't necessarily mean you shouldn't approach them. But yeah. Also 2019 is not recentish. Recentish probably means, very recent, last year or so. Is what you should look at. Company that is in 2019 is not hiring as aggressively as a company that just received money. Either way, figure out. I don't think that number is that bad. Okay, 95% of them are not hiring, but I could be wrong. So let me know. If they hire in the US, is it possible to convince them you hire willing to work in the same time zone? Yes, that is something you have to sort of do, right? Convince them that you do work in this use case. Thankfully, you can do one of two things. Number one, you can get a lot of reviews on Upwork that say the same. I did that. That helps. Or you have to tell them, hey, I'm a night owl. A lot of times people say, hey, I work from EU. If they're the US-based company, anyways, you're working remotely. Don't do that. I say don't fake your location. But yeah, it's not too hard to convince, especially for EST, because EST sort of overlaps with India time. If you're doing 9 to 5 EST, that's around 2 p.m.-ish. 2 a.m.-ish India time, which fairly common for software developers. I know it's cliche to say, but if you find any startup that hires remote engineers from India, then what would be a step-by-step process to approach them by summarizing your experience and observations? If they're open source, then contribute. If they're not open source, then you have to reach out on Twitter, job portal, go there and apply. Keep your resume very international, by which I mean, don't write Bangalore as your location anywhere, write remote everywhere. If you have GSOC or any other remote internship, that helps. Keep your resume very, lean and tech specific, and, don't mention your location at all until you get that interview. But yeah, that's pretty much it. Either find an open source company where you can show your work upfront, or one more thing you can do is, whatever the company is making, build something similar, build a library in that niche, build something on top of it, create a landing page for their company and show it to them, things like these. Seeing your career fairly successful. Okay, thank you. Appreciate it. Any tips about burnout? Standard, spend time with family, work out, all that jazz. All right. Oh, I should look at that. What's up here? I say. I will look at that soon enough. This is the wrong Discord, which is why I don't see it. I faced a weird issue when I was running all the tests, npm test. 1 or 2 tests are always failing. If I rerun, they might get passed. That's what we call flakiness, sir. I have founding the solution for more than 1 month. You will have to share the exact code. Can you quickly check on your machine? Let's see. Oh, fucking A. Sorry about that. Thank you, Akash. Let's see. Can you quickly check on your machine? What was the code again? Oh boy, that's a lot of code. What is this? I cannot test right now. I'm happy to do it after the class. But yeah, test flakiness comes for a bunch of reasons. You might not be mocking some services. So, sometimes I'm thinking of when I've seen this in the past and what the root cause was. Are you mocking out all the services? A lot of times, there is a service that might work in a flaky fashion. For example, if you're trying to put things in a database, the first time it might go in. Second time it might fail because something already exists with that primary key, right? So that is one reason I can think of it. Baki, the best way to debug is go to that test, comment things out line by line, and go from there. Basically, comment out all the if it's calling a function, comment out a certain section, see if that fixes it, and basically try to boil down to that specific line and then fix it. But happy to look at it after the class as well. Is there anything else that you had? Refresh. Alrighty, that's it. Chat one more time. We have to do a YouTube live in an hour, so I'll probably be calling it soon enough. Learn together. This was a random idea I thought of. Okay, I post these 6-hour videos. I'm assuming people are watching it. What if they can watch it together? And like go to a website where there's a video and 100 people are watching and 100 people can watch it together, and then every 20 minutes take a pause. And if they have doubts, ask them, things like these. What are playwright tests? That's what end-to-end tests are. Can you deep dive in that in an offline video? Will be helpful. Sure. I was going to do integration tests. I might do end-to-end tests if we have, depends on when it comes. It'll probably, basically, yes, I will do it. Question is when will it come? Playwright lets you do, or Cypress, both of them let you do end-to-end tests. End-to-end test means you actually open a browser, click a few buttons, and which sends a request to the backend responds, and then you get something on the front end, and you do a actual test on the front end to see the visualization, something changed on the front end. That's what Cypress lets you do. That's what I was saying. I contributed to a GSOC library that's very similar to Cypress. It's actually maintained by a bunch of Indian people. If you look at my most recent GSOC video, like a 3-hour video where I try to contribute, there I contribute to a similar library that lets you do end-to-end tests. So these are like 2 libraries that are popularly used, Cypress and which one do you Playwright? But there's a third one that some Indian folks are creating. All 3 of them let you do the same thing, end-to-end tests. Happy to do a video on it. Why do we need to mock if you are connecting to a database? We can just assume that database call will always succeed. When you're not connected, we are connecting to a database, right? If you look at our code base, what does the code base say? Code base says Prisma client.sum.create. It will try to hit a database. It will try to connect to this specific database, and there is nothing running over there, which is why you need to mock the call. If you don't mock the call, it will throw an error right here. If I remove the mock from index.test.ts and rerun npm run test. As you can see, the test is stuck and eventually it will time out because it tried to hit the database is down. Okay, yesterday's tests doubts remain stuck for 3 days. Let's see. Do we need to add mocks in every test file? Yeah, you can just you need to import. Now you just have to do this, right? So yes, you have to do this in every file. v.mock./tv. You put all of your mocks at the top of your file like this, and you have to put it on top of every file. Guitar stream when the guitar went away, dude. It was for a friend. They took it away from me, so not anytime soon. Do we okay, answer that. Testing for LLM applications is super difficult due to inherent generative nature. Do you have any tips? There are a lot of companies building on this. I'm assuming you're saying it's difficult because the response is different every time, or the LLM is unpredictable. I know. I have not. One of my juniors is doing exactly this startup. They got into YC last batch. Testing for LLM apps. No idea how they're doing it. I'm sure there's like a new paradigm of testing frameworks that will come for this. Yeah, it is in a big pitfall in the current LLM space, which is why YC is funding a lot of companies in this specific niche. How much bounty do we need to get a referral? There's no number. It's just whenever I get an opportunity, I just open the contributors page, look at the top contributors refer. So it's not less about the number, more about the number of contributions, I guess. Testing for LLM application is super difficult due to its inherent. Okay, answer that. About the port being used error, most libraries have port. Okay, answer that, right? They do have this that they will run on a different port, but how will you know what URL to send a request on, right? If you put localhost on 3000 here and something was already running on 3000, it means it's decided to run on 3001 now, but your test still has localhost on 3000 written over here. So if the port becomes unpredictable, you don't know where you would want to send out a request, which is why it's just easier to use a library like Supertest. I learned basics of Anchor and Web3.js. I saw a video yesterday. How do I proceed with that? What can I build? There were a few ideas I threw at the end of that video, which was, transaction sweeper isn't working. You can actually create a contract, like an escrow kind of a contract where you put the money and eventually let people, take it out. That'd be super interesting. Actually, maybe not. Escrow is probably this is not the best use case for an escrow, but maybe you can build a more simple freelancing marketplace where there are two people, where an escrow contract becomes like an obvious one to create. Escrow is the most simplest contract that you should just create once. And Anchor. Are there any active open source projects with high number of issues? Do you mean in Web3 or do you mean otherwise? In otherwise, there are many. In Web3, I wouldn't say there are a lot of issues. Solana has a bunch of them. Drift protocol, for example, I don't know how many issues they have, but most of their code is open source. So, look over there. Even if you understand the code base, I think it's a great start versus trying to solve an issue. But I don't know if you can find a library on day zero to, where there are a lot of issues, specifically in Solana. How to test WebSockets and media inputs? Testing WebSockets is a good question. I have no idea. I'm sure there's a library that lets you do it. Let's see. Maybe just even lets you do it. Testing WebSockets. NPM. Cypress WebSocket testing. Seems like there's a library that Cypress folks have created that lets you do it. Let's look at the code. Side.stream request. Config options. Null. Pipe. Yeah, seems like there's one library that lets you do it. Yeah, if you have a WebSocket layer, it'll be so hard. Yeah, it'll be pretty hard to test. Basically, it's pretty non-standard to do this. Usually you test HTTP servers, you test normal functions. I've not seen this happen before, basically is what I'm saying. I guess I've worked at companies that use, there you go, Super WS test. That sounds slightly, no one downloads it. Probably don't use this. Yeah, the reason there aren't a lot of libraries because this isn't done too much. This also only is downloaded by 2,000 people, which means, it's not a very actively used library. This one still looks decent. Jest WebSocket mock. Set a release, just complex WebSocket interactions. There you go. This one probably is the one you want to use. Yeah. Alrighty. Learned. Okay, answer that. Can you explain assertion libraries? The same thing, right? Rather than assuming this is what you mean. Rather than expecting, another thing you can do is use something called an assert, which, as the name suggests, lets you assert whether or not this specific thing is, equal to be dot equals or dot expect, whatever the syntax. Basically, assert and expect are used interchangeably pretty often. Is that what you mean, or do you mean something else by assertion libraries? Are assertion libraries something else, or is it just testing libraries that let you assert on data? What is the difference between assertion libraries, testing libraries, and testing frameworks? Or maybe it's something else. Assertion libraries are tools that verify that things are correct. That makes sense. Basically, this expect is something thankfully a testing framework gives you, but a lot of times all you have to do is expect or assert data. You don't have to do all the other testing. So assertion libraries will give you functions like these that just let you assert, is this equal to this? Basically let you do something like this. If A equal to B is not true, or if A not equal to B, then throw some error. An assertion library just lets you do this thing by doing, by giving you functions that look like this. Okay, assert 1 equal to 1. So yeah, that's what an assertion library is. But a testing library gives you other things like mocking, spying on top of this. Alrighty, looking at Akash's this thing, and then we'll go from there. Browser is not able to set. Oh, you did mention this. Okay, let's see. What did I ask you to do yesterday? Did you refresh counter questions? So I'll reply here. Try 3. Option equal HTTP only, same site. True. Return rest. It's working, but defeated the purpose of using cookies over local storage for security. Why is that? The benefit of using cookies over local storage is that you don't have to necessarily store the thing finally in your database, in your local storage. What's the benefit of using a cookie over local storage? Number 1, it automatically gets set. Number 2, it's slightly more secure. It's working, but as same as CSRF attacks. Okay, let's see. Your options are this, and what do you want to make the options? You want to restrict the domain, and when you restrict the domain, what error do you get? This attempt to set a cookie via set cookie header was blocked because domain attributes was invalid with regards to the current host URL. It's telling you zippy-x.vercel.app. Have you tried putting HTTPS call? Not that, probably shouldn't fix it, but maybe try that. This, oh god, text to image. Image to text. That is taking a long time. Basically, I would just Google this error and see what's up. Try putting the whole URL here. I don't think that will fix it though. The set cookie attribute is invalid with regards to the current host URL. Exactly. The domain in set cookie header says this thing, but the request is for localhost 5000. That's a different origin invalid cookie. It is impossible to set cookie for a header from one origin to set cookie from a different origin. Can only set cookies for this thing. Your front end and back end are separate. Try this. Okay. Yeah, that makes sense. So try this. Host your front end and back end on the same URL. How can you do that? Is your front end in React? I would assume yes. If not, probably it's in Next.js. Either way. But if it's in React, it's easy to do. If not, then it'll be a little hard. But okay, try doing this. And that should most probably fix your error. Host your frontend and backend on the same URL. How can you do that? If you have an Express backend, which I will assume you have, maybe you don't, maybe you have Next.js. Then, with all the endpoints that you have, create a public folder. Inside the public folder, put your React bundle. What is your React bundle? Whenever you run npm run build, the final code that you get in dist, put it in the public folder, and then, do a app.use static public. Basically, Google how do you serve a React application over Express. Host both your frontend and backend on the same URL, and then I think this should work. That's what this error over here states, and most probably that makes a lot of sense. Okay, you cannot set cookie on a specific domain from your backend on a frontend URL. You are trying to set the cookie on zippy-x.vercel.app when the request is coming from whatever zippy-backend.vercel.app. So That's what I would assume this specific URL, this specific request is coming from. So I think the only thing you can do is host your front end and back end on the same URL. Try that. That doesn't fix it. Let me know. I think that should fix it, I think. All right. Let me know if it doesn't, though. You have my WhatsApp. Any more questions, guys? If a company that uses Java framework offers a job to a fresher, should they accept it? Why not? Not really. It's not outdated. Most companies will. You should take it. We can mock a database through Jest. Then why vtest? No reason. I was going through testing Prisma with the official docs. They have very nice docs on how to test using, how to test Prisma using, or do like unit tests in Prisma and then integration tests. And they were using vtest. I was like, okay, let's try this. That's all. You can totally mock in Jest and do it fairly easily. I'm making Book My Show clone. What are the problems I should fix, like concurrency related problems? You will have to. Biggest problem in a use case like this is locking the database. If there are two people who are trying to select the same seat, you have to make sure they cannot take it. That's the biggest problem, right? There's no others. Everything else is simple full stack. So you just have to understand a little about how databases can be locked. And when two people try to select the same seat, then you have to sort of move that specific row to currently transacting or something like that, and give the user 5 minutes to transact. If they're able to transact, then you take over that seat. If not, then of course the seat becomes free again. So you have to, number one, have some sort of a logic that locks a specific seat for 10 minutes, because the user might take 10 minutes to pay, and for those 10 minutes that seat should remain locked. And number two, if two people try to hit the same row and try to take the same row at the same time, then you have to, basically that specific logic needs to lock the database or that specific row in the database and make sure only a single user is able to capture it at a time. That's the only complicated thing there. Did you have your dinner yet? Before the class I had something, and then I'll have something now, and then we have the YouTube live. All right, let's call it here, guys. We are PR. Nimit is doing that. Feel free to do that as well for like practice. It might not get merged, but Nimit is doing the same thing. Features for chess. Chess method, there are a lot of things. Shareable links, puzzles, learning chess from scratch, things like these. Like a lot of things you can do. Solana companies, any pump? It's normalized a bit since the last pump, but still pretty good. Rust generates lifetime. Should I learn Anchor next? You should be able to write smart contracts now. If you understand lifetimes, then that's the only hard thing that's left before you can dive into building contracts. Did that founder reply anything on me? Vishnu. So you are one of those two people. He said we are hiring next month. He's actually not a founder. He's a person from cohort 1 who maybe, I don't know, maybe you're asking about a different thing. But person from cohort 1 who works in a company and needed 2 engineers. I gave him, I think, yours and another person's name. And he said, oh, I'm not sharing my sheet. Doesn't matter either way. And he said next month he will reach out. Basically gave me like, he told me उसने 1 महीने के लिए. So let's talk to him. Maybe basically 15 more days I'll talk to him and then we go from there. Alrighty guys, we will call it. I will see you in YouTube at 10 p.m. We'll do some live reviews. There are like a lot of pending now. And it's a good way for me to be accountable if I'm live on YouTube to do them. With that, let's end it. I'll see you guys next week. Bye bye guys. Have a good night in case you're sleeping. If not, I will see you on YouTube in an hour. Have a good night. And let's call off the recording.